So the Laplace transform for last week, we learned about the we take from one function to another function, that's why we call it as Laplace transform, which take you from one set of function to another set of function. So for example, for last week, we have this is the improper belum lambat dia keluar. Improper integral from 0 to infinity, e of e to the minus of st to the function of ft dt. Ting macam a bit lambat keluar. So this is the example. So we have the Laplace. So this is example when we take it the Laplace transform of 1. So this is the Laplace transform of 1. Which means we'll place 1 into the function. So let's say that the a approach infinity of the integral, so which is a approach infinity, we have a 0 to infinity negative st dt. So because we can't evaluate this infinity, so that's why we use the improper definite integral. So we assume that s is greater than 0. So this is the assumption. With a to the infinity s. Limit a to infinity equals to 1 over s, because we assume this one equals to 0 because the value is e to the minus of infinity, because we replace it. So, if we replace the a to 0, the value of exponent 0 is almost near to, has almost no value. So that's why it's this one equals to 0. So we have 1 over s. So this one equals to, so this is the version of what we learned last week. So for today, we will continue with the, also we have other function by referring the table, which table in You can refer this table. Table of Laplace transform. So we'll continue for today the properties of Laplace transform. So this is the linearity properties. So if L to the function of ft and function of gt axis, and if alpha and beta are constant, so this is the value that you will get. For this example, when we add the alpha and beta, so we just times AL, yeah, it's become like this, a to the power of so L plus beta L times to the function of gt, and then you get this one. So this is we transform it to the other function, which is the function of f and g s. We can see this example. So this is the function Laplace transform. L is the Laplace transform. The notation is L. This is the Laplace express of alpha to the function of ft and beta to the function of ft. So we have two functions here, which is ft and g to the power this one times we can consider. So we expand it to the form of integration. So you have this one, integration of 0 to infinity. You have of exponent negative st. So this is a mass. And then we substitute, because the original one is est dt. So we just add this function into this one. Yeah, this is what we learned last week. So the basic one, basic. So you just add the function of this one into the integration. And then this one you just get alpha times e to the negative st, and then integration of b. So we have two function of integration here. And we can summarize it into this one. So this one, how we get from this to this one. So this is the steps on how you get this Laplace. So we'll try to do some example. So for example, the question is find the Laplace transform of the function ft equals to 5t cube plus 6t. So by referring the table 1 Laplace, and try to copy the table. Sorry, I couldn't copy. But never mind, we just continue. So this is the function of Laplace transform. We have L, the function of ft. So we need to find the Laplace transform of this function. So you just substitute the value, which is this one, Laplace. Yeah, we divide it into the function. So you have to just first T3 and plus 6T, which is this one. And then, yeah, you 5, you put outside. And then 3, this one S, by using the table. I think you can refer the table later. Yeah, this table. I try to copy it again. Okay. Yeah. Yeah. So by referring this table, I think, yeah, the second one, this one, this table. You can see, cannot edit. Oh, yeah, okay, cannot. So you're referring this table and the table Tn n equals to 0, 1, 2, 3. And then the Laplace transform is n plus 1. So you just follow this table by substituting the value. So our n is, this one is Tn. And this one 1. So 3, you just follow n plus 1. So 5, you bring it outside of the table. And 6, bring it here. Just calculate by using a calculator and then you get this answer. So this is the Laplace transform for the function of ft. So I get this one. So next question is something almost the same, that we have E here. So by referring the table, which is this one, n s n plus 1. So our n is 4, is 4 plus 1. So this one will bring it outside the number, the 2. And how about if we have exponential e? So you just referring the table again, which is this table. And this one, EAT, the third one, fourth one. So the function from the table, from table of Laplace, we have if the function is AT, and then you have the Laplace one is minus A. So if your T, then your A is negative 4. That's why you have 1 plus 4. Just this one. You bring it to here. And then just by using calculator, you'll get this answer. Okay, so next example, I think this homework, I think this question I've included in the tutorial. Anyone have done this example? Example 4.8. No, nobody do it. Did anyone get the answer? I think don't have solution for this question. Example 4.8. So did anyone? Nobody? Nobody do this homework? Tidak yang buat. Kau you don't know how to do? Ada kah yang buat? Tengok ni. Don't know how to do. You want to start, you try to do, but don't know how to start. Is it? Okay, never mind. I will show you the. Logit sudah cancel. Yeah. Okay, for example 4.8, given that cos AT equals to this one 1/2 EAT plus E negative AT, where A is constant. So by applying the linear property, find the Laplace transform of the following function. So this is the function ft equals to cos AT. It's equal. You can refer the table. Okay, so from this function, we need to find the Laplace transform of cos AT. F1 EAT Laplace. Yeah. So this is just a proven because you can directly get the answer from the table. Because from the table, your final answer, you should get s square minus s square. So this is the solution or step on how we get this one. Because from the table, this table, you can see, yeah. So this is the function cos 80, and then you get the Laplace s over s square minus s square. So for this question, you need to prove on how to get this one. So this is the steps on how you get this one. 1 s plus a e80. This one also, yeah, right. E80, e negative 80. On why you get this one? By referring to the table. Yeah. This one, e80 equals to 1 over s minus a. You just substitute the value by referring the table. Yeah. And you will get 1 over 2 s plus a plus s minus a. Yeah, macam, oh, I think my screen sharing has stopped. I need to share. Yeah, I think I have log out. Keluar. Maybe the line, problem with the line. And try to share again. Okay, just, yeah, key in the value. Okay. Let's calculate, and then final answer, we will get this one. So this is the same value with the table of Laplace. So this is the final answer. But this one just have, I think, more to proven on how you get this answer from this one, ft cos 80, and then you get the s square minus a square. So for the question, usually not this directly. Next, we'll continue with the first shift property. So to find the Laplace transform of function multiplied by exponential factor, the theorem is called as linear shift property. So previously, the linear property. So next is the first shift property. This is the theorem, which is Laplace of ft equals to fs, and a is constant, then Laplace e of at ft is equals to f S minus A. So this is the first shift property. Why is it called first shift property? I think we'll try to see few example. Yeah. So this is the using the first shift theorem. Find the Laplace of E3t is great. Different with this. Yeah. Well, this one we involve the function with a plus. Plus or minus, you have two function. So this is the we call it as linear. So different with this one. This is we combine two function multiply. You consider it's multiply. You can see two function here. Yeah, that's why. So this is the first shift theorem. So we can see we try to do the example one, which is Laplace of E3t times with T2. By referring the table, from the table, is n plus 1. So we try to do it. 1, n is 2, s 3. So this is the first one. And then second, f s minus a goes to f minus 3. This one, how did you get? I think we have noted. So if you s minus 3. Yeah. So for the first one, this one you consider s fs. Then the second fs minus a. Then you substitute the a equals to 3. And so this is the combination. 2, this one you substitute. Our s is this one, s minus 3. So next example, et sine 1 over t. Yeah, I'll try to do only one example for this homework. So for this question B, need to find the Laplace of E t sine 1/2 B t. So I need to find the first one, Laplace sine t. So this one you're referring the table. So just replacing the A, 1/2. So S square plus S square, 1/2 square. This one, you get 1/4. So 1/2 4 plus 1. So this one, the first one, you get this one. So you need to divide for the first shift theorem. You try to solve, for example, A, you try to solve this one first. Yeah. So this is the first step. And then second, you combine the Laplace E and T sine of T equals to F S minus 1. Then 2, tariklah di sini. 4 S minus 1 square plus 1. What equals to 4s square minus 8s plus 5. So you get this as the final answer. So this is the answer for example B. Same with the C. We first you need to calculate this one. And second, the combination we all think I try to do C lah lagi kali ya, for more understanding. Jadi di last one. Okay. So for examples, question C, negative 2t cos 3t. Negative 2t cos 3t. So this is the Laplace transform. You need to find the first theorem. So our first function, as I mentioned, you need to find this one first. Lepas tu baru this one first. Lepas tu second, all lah, combination. So the first one is Q. Function is ft equals to cos 3t. So this one referring the table. Kalau cos 3t, table refer table, cos 80 plus square plus a square. So you get your Laplace for cos 3t equals to, just copy, s square plus s square. S square ni just masuklah value 3. So 3 square. And then you get s over s square plus 9. So this one for the first theorem. And then second, you combine semua ni. Laplace e to t cos 3t equals to f s minus a. To f s plus 2. Plus 2 because you punya exponent. Ni lah. I think this one sama macam yang tadi tu lah. Just negative 2t. Yeah. You need to refer juga this one, the table. Okay, confusion. Why did you get this s plus 2? Is because we refer the table to for exponent. E at t equals to plus s minus a. So if your e negative 2t, you get s minus negative 2. That's why you get s plus 2. So you take this value and then transform it to this one. Oops. Yeah. Yeah, then we continue. So our function for fs plus 2. So just substitute the value that you get from here, the first theorem, and then you get s plus 2 over s plus 2 square plus 9. Yeah, clear how to get this one. But the s here, you need to substitute the s to this. So s goes to s plus 2, and then same one, this one, s plus 2 square plus 9. So you just calculate the value s square plus 4 s plus 4 plus 9 s plus 2 plus 13. Yeah. So this is the final answer. Okay, so far, okay. Anyone have question? This one for example C. Example. Okay, this example. So far, is it clear? Any question? Okay, so I will continue. Yeah. So this is the other example for the first theorem. And this is, how did you I didn't differentiate between the linear and first theorem is we have two function lepas tu times di sini. Okay. So first one, this one is a bit complicated. Just times t times e t times e times e, and this one times e. So you get this one. Applies TET, applies t square ET, applies 1 over 60 cube ET. And then this one, you're referring D. Yeah, I think this already simplified the answer. So this one same, need to find for each of it. Yeah, for example, TET, find the Laplace of T first. T, then you find Laplace of T ET. Same method, same step with the previous ET. And you get this one. So I think you can try to do it yourself. So the method is try to find this. T. Yeah, I try. Minus. Yeah, because from the table, T equals to 1 minus S minus A. And then the function. Yeah. So just referring this table, and then you'll get this one. Okay, same method with the previous example. You just so next we'll continue with the differentiation of a transform. So if you have Laplace ft equals to fs, then n equal 1, 2, 3, and 4. So this is the transform. Laplace transform of t n equals to negative 1 n dn over ds in fs. So how to remember the normal one is you just have t in here. Yeah. And then dt, usually you use the function of dt, but this one is different. So you need to remember this transform. So anyway, never mind, you look the example. I think this is the formula. Yeah, same with this one. So we try to do example 4.11. So given that Laplace EAT equals to 1 over ST, so this is from the table using the formula. This is the formula for what you call differentiation of a transform. So you need to find LTET. Oh, I think I have problem. It was out again. I think I need to rejoin. Yeah. Ya, balik to keluar. Okay. Coba ya, tengok dulu bateri berapa persen. Okay, we continue with the example. So we need to find the differentiation of a transform. So this is the equation. This equation. So you need to find Laplace EAT. So this is from the table. I don't know. And this one from the table. Yeah, but given also in the question. So you need to find this one. So -1, you just substitute the value. -1, your n is Gn is equals to 1 because it's on n. So that's why the n here is 1. The n or ds1. So when you have 1, so nothing to write now, times 1 over SA. So this is for t plus t, and then this one plus EAT. We combine it. And then you just times the answer. Okay. I think this question is quite simple. We will try to do more complex. Yeah. So is it okay for example 1? This is the function for L plus LT, and then this function for plus EAT. So this one you get from this one. Yeah. So next we continue with the example. Masih banyak kan? Let me check. Okay, I think we still have time. So I continue with the example 4.12. We need to find the Laplace transform of ft t cos t. We want to, yeah. Okay. So I will replace t cos t equals to -1 and this one, this equation, dsn sn fs. So ft cos t, so same with the previous one. We divided one. Ni pecah. This example. Yeah. This one, how did you get? It's from the table for cos t. Yeah. Cos t square plus s square. But if your a is 1, you just substitute the value to 1. That's why you get s square plus 1. So this one from the table of Laplace. Okay. And then continue. Place t cos t equals to negative d dAs. Yeah. So this one, suppose the n here, you substitute to 1. 1. This one also 1. This one, how did you get? I get from this one. Yeah. If 1 is and the other. Okay. And then just calculate negative, you put it outside. S square plus 1. Plus 1 square. And just calculate the answer equals to negative. Okay. So the answer, how did you get from this one? Because you are referring the what you calculate from here. S over S square plus 1. So your S in yeah, T. Yeah. Because T from the table also Tn equals to yeah. So we're gonna combine this one too. That's why you get this as the final answer. Okay. Sure, sorry. 42. Okay, so next we continue with the unit step function. We have the theorem Laplace transform of unit step function. So previously we learned about the first shift property, and then so next we have second shift property. So if our a is more than 0, and then the Laplace function of ft, which is convert to the other function of fs, we have this one, Laplace t minus a, h t over a t minus a goes to e negative as. Yeah, so you can see. Now this is Laplace transform of the step unit function. I think for more understanding, we can try to do the example. So for the second Laplace, usually have the other function or the unit. So you can see what the difference from the other. Because now we have h here. So this is the second theorem, second shift property. Try to solve this function and the Laplace transform of the following expression. T minus a. Yeah, so this is the question. So you need to find this Laplace for this following expression or equation. So 2t minus 1. So I think this question have simplified. Okay, I try this one for the inverse. So for this example, you need to refer this equation. Yeah. LHT over A Laplace HT minus A equals to E negative AS over S. The condition of A must be then 0. So by referring this, we'll try to solve this one. So H is so we'll try to solve the first one first, which is this one. Laplace 2t minus 1 h t minus 1. So equals to, you can refer this equation. So you have 2 here. That's why 2 e negative s over s square. I think you need to do it separately. T minus 1 because you have t square, t minus 1 square here. So you will have 2h t minus 1 square. Yeah. So when you compare this one with this, equation, you'll get the answer. 2h, so you have 2 here, negative e, a is 1, and then s square, because you have square here. So same with this one. So this, the others is same. You try to do it. So this one with this one, you can make it square. Okay, is it clear for this example 4.3? So far, okay. You can see this. Become. So I will just continue to catch time, and you can try to do this example. But if we have more time, I will try to do it one or two example from this one. But for now, we just continue with the next subtopic, which is inverse Laplace transform. So what is inverse Laplace transform? So we have this one, what you call as inverse, because you have -1 here. So finding inverse Laplace transform is the reverse process of the finding the Laplace transform. So we have another table here for the inverse. Yeah, this is one, the complete one. Because this also have the second, second shift property. Yeah. So you can refer to this table. So the table will be provided during your exam. So you don't need to remember this table. Okay, so we try to do some of the example for the inverse Laplace. So banyak kali inverse. Not so much. Before continue to the next subtopic. Okay, we try to do example 4.14, which is we need to find the inverse Laplace transform of the following expression. So for first question, find the inverse Laplace transform of the following expression, which is, okay, if you see the inverse, you have -1 because it's called S inverse. So the function is 4 over S. So by referring the table, yeah, because inverse, you need to start looking from this one. And our function 4.13, yeah. Yeah. A over S. So A from the table, A over S equals to A. So the answer is 4. Yeah. So if the inverse, by looking the table, you should looking from here, different from the normal Laplace. The normal Laplace, you look from here. So different with the inverse Laplace Fs, you start looking from the right. So next example is for find the inverse Laplace transform for the following expression. So the Laplace, inverse Laplace 6 over S4. 6 inverse Laplace of 6 over S4. Okay, 6. So as you can see here, like that. So you're looking from here, from the this one, no. Yeah, I think this one. Sn plus 1. Tn. So if you get so you're find this variable n is plus 1. And then this one kan. Yeah. Then you will get t equals to 3 because n 3 plus 1 kan still 4. This one also 3. So you get the inverse Laplace of 6 over S4 equals to T3. Okay. Same with example 1.4. On the next example, next example is 1 s minus 4. We need to find the inverse Laplace. So same method. We look from here, 1 over s minus 4. So this one, right? So it should be negative AT. So our A here is 4. So you get your answer goes to E4T. So this is the inverse Laplace for this function E4T. You can see, okay, you get the same answer. E4T. Easy, as long as you refer the table. So next, inversion using the first shift theorem. You to try to do the so this is the equation you can refer. If Laplace of E negative AT for the function of ft equals to f s plus a, then the inverse Laplace is equals to Yeah, so this different you can see is the inverse. I need this one. So kali ini like this. So this the inverse. This is the example. Okay. So for example, this one, we find the inverse Laplace transform of the following expression. So you need to find the inverse transform of 2s plus 5 square. So for the inverse, negative 80. Yeah, I try to pisahkan dia dulu. S plus 3 minus S plus 3 cube. Ya, cos yang inilah. S plus 3 dengan saya tengok 2. And you try to bring the 2 to the front. Now plus negative 1. 1 over S plus 3 minus plus negative 1 S plus 3. Yeah, this one a bit complicated. Negative S plus A. Yeah, you need to refer the table for again if one S plus 3 is, if this one from the table, S minus A. And you get 2 minus, and then this one you substitute to 3 because our A is 3. A equals to negative 3. F S plus A. This one you get from S plus A. Yeah, it's same with the first shift theorem that we do for the normal Laplace, but this one different because it's just it involves the inverse Laplace. The next one is almost the same. We need to find the inverse Laplace of the following expression. So this is the inverse Laplace. So same with the that we just bring out the 3/2 here. We get Laplace 1/1 minus 3. So this one E to T, same with this one. You refer the table of Laplace. Okay. So this one you can try to do it. Try to solve this equation or expression to find the inverse Laplace. This one. I think you can try to do it later. Page. Have 5 pages. Okay, and the next subtopic is inverse Laplace transform of rational function. So if a linear factor s plus a gives a partial fraction, which is a over s plus a, where a is constant. So this is a linear function. Then repeated linear factor, which is they have d square here, give a fraction. So yeah, this is for linear fraction. Just repeat. And then repeated linear factor is 3. Sama juga lah. So an s plus a, and then continue s plus a square, and then the third times linear repetition of linear factor s plus a cube. So this one around this repeated linear factor, which is s plus a exponent with n. So I have plus, I have this one, an over s plus a n. So n are a non-constant. So an irreducible quadratic factor, for example, this gives, this is still linear factor. I think you don't need to remember all of this. Just remember this one. Yeah. So this quadratic factor. We try to do another example for Laplace transform, for the inverse Laplace transform. We have first equation. So we have two repeated, as you can see this one. Yeah, repeated linear factor. So you can use this equation. So we have A and B. The first one, A over S plus 1. So this one and second one. And then plus B over S minus 2. Then solve it. A equals 2, sorry, A 1 over 3 and B equals to 1 over 3. So this is the example. You just continue, copy the question. So you just substitute value for A. From here, you bring it to here. By substitute the value, subs A and B. Yeah. 1 over 3 s plus 1 and 1 over 3 s minus 2. And so you just take out the 1 over 3 outside and find the inverse Laplace of 1 over s minus 2 and then s plus 1. Yeah. It's almost same because this one negative. Yeah, this one 1. Yeah. The arrangement is different, but it's almost the same if you try to do it this first and then this first. So you get your final answer. E negative E 2t minus E negative t, because by referring the table 1 s minus a, the linear s e a t. So this one from the table. So if you a is 2, then so you get this one. So this is your final answer. So from here you refer table of Laplace. Okay, that's all for the part 1. So I think we have about 15 minutes. We will continue with the part 2. I think we have about 10 pages. I think not so much on the second, on the part 2. So for the part 2, we will continue with the convolution theorem, Laplace transform of derivatives, and solving first order differential equation with the Laplace transform. So we continue with the convolution theorem. Convolution theorem also involves the inverse Laplace. Yeah. So we have two functions here, which is function of f and function of g. So this is the combination. So that's why I call it convolution theorem, because we involve two functions here, which is function of f and function of g. Okay, f and g. So we'll do a simple integration, which is integration from 0 to t, and then function is u, fu and g t minus u. So I need to remember this equation for the convolution theorem. So we try to do some example for the inverse Laplace transform using convolution theorem. So the first example is we try to separate this equation, which is the first one, 1 over a plus 1 and then we times with s minus 2. So we choose this one f ace and this one as fg. Okay. So fs equals to 1 over s plus 1, fg equals to 1 over s minus 2. So in which the inverse Laplace fs equals to e这样 So fs equals to 1s plus 1 gs equals to 1s minus 2. So ft equals to negative t, gt equals to e to t. Yeah. This one refer table, and then this one you're referring to this table here and to this equation fu g minus u. So this one d fu and g t minus u. And then the t, you just substitute it into value here. T minus u. And then t, just the value. And then the question asks to find the inverse Laplace. And you don't have enough spaces here. Okay, never mind. I just continue here. Inverse Laplace of 1 over s plus 1, s minus 2. So equals to 0. Integration 0 to t e negative u times with e to t minus u. So you just combine here to here. This one eu to here. Then you will get e to t and you try to integrate a negative 3u 0 to t. Just integrate and substitute the value 0 and t. T and 0 here. Then you get the final answer 1 over 3. Okay, so this is the final answer for this question A, 4.16a. Continue. For the next example, I think you can try to do it. And you'll just give the final answer. The final answer for B is 4t minus 1 over 2 sine 2t. This one for B. And then answer for C, 1 over 4. Okay. So this is the answer for question B and example 4.16c. Then you can try to do it yourself. I don't know, maybe I will include it in the test 3, maybe. So maybe you can try to do it. Okay, so I think we have around 5 minutes. Finish here. I think we have only one subtopic, which is transform of derivatives. So this is the transform of derivative, which is start from the yt, s, and then the transform. This is, then the final one is some. I think we can just proceed to the example 4.17, which is to solve the initial value problem. 0.17. It's a bit long solution. You never can try to do one example. For example 4.7, which one you prefer? I think maybe B. I didn't try to solve the B. 4.17. So for this one, 1 over 2 cos t. So this is the answer for question A and C. So I'll only show the example 4.17b. The solution is a bit long. So this is the question for B. Y to T. Yeah. Okay, so what is T? Ini kan, what is Y? Yeah, actually same with like dy dx, for example, and then dy square, dx square, yeah, second, and then this one third, dy, yeah. So this is the meaning, and then the condition is y not equals to 1.
The slide is gone.
Sorry. Thank you for informing me. I try to. It's almost. I think it's 4 already. I'll try to show the last example. This one, last one. I think I have signed up. No, I was disconnected. I try to join again. What's problem with my line? Still connecting. Yeah. Never mind, because I cannot join. Cannot. Okay, sorry, I have problem to join using my iPad. So I think we have about the class. I think almost, not almost end already. It's 2 p.m. So I think we are done with the transform derivative. Just a few example left. So I think I've shown the answer for A and C. So did you get the answer that I just write just now for A and C?
No.
No? Okay, never mind. I will give the answer later for A and C, and then I'll also share the solution for question B. And then I think we have left with 2 more examples. Oh yeah, since I have problem to share my screen, then I will provide the example 4.17b and example 4.18 and 4.19. So I will share the solution for these examples in ITEL, so you can refer the example there. Okay. So any questions so far? Did you understand what the Laplace and how to solve the problem?
What for S3?
Yeah.
Yeah.
Yeah. Okay. To inform you guys that we will have tests for next week. I think same time with the class, which is from 2 to 4. Usually your test 2 hours with Dr. Farhana for test 1 and test 2. 2 hours test. Is
Yes.
it?
Well,
Okay. So same time I think. The venue I will confirm it later. But we will cover the question. Yeah, for the tips. But yeah. So I try to check it again. Can I find? So for test next week, you only go for cover only for part 1. Okay. But for the final, cover part 1 and part 2. Yeah. Okay. Is it clear? For test, you cover only for part 1, and then for final, cover part 1 and part 2. But for the tips, maybe I'll see it later. Yeah. I will inform you guys again. Okay. That's all.
okay.
Okay. Thank you. Final exam, 4 question, but have sub question for each question. You need to answer all question. Yeah, total 4 question. For my part, um, 1 question only lah. 1 question, but you have A, B, and then part B. Yeah, the part line is sub question 1, 2, 3. Yeah. So for final, we have 4 question, and each question about 25 marks. So total 100 marks. You need to answer all questions. Okay. Any more question? No. Okay, thank you. For the attendance, is it everyone has scanned? I think 3% have not scanned for the attendance. But yeah. Ya, 3 orang itu. Kelvin Dino, Alexander, and only 2. Yeah, only 2 absent. Is it absent or have problem to scan the attendance, the QR? Yeah, Alexander and Kelvin. Are you here? No?
Excuse me, Kelvin, I haven't scanned my attendance yet.
Okay, Kelvin and Alexander. Yeah. But 3% ya? 57. Lagi 1 orang. Ya, Kelvin. Oh, ada 3 pula. Ya. And one more person. Betul. Okay. One person is Muhammad Arif. Kelvin, Alexander, and Muhammad Arif Shah. Okay. Kevin, Alexander, Muhammad Arif. Okay. Let's scan their attendance. So that's all for today. See you this Saturday for those who joining for the civil night. So I heard about 17 of you guys are joining. So see you. Okay, thank you everyone.
Thank you,
Thank
doctor.
you, doctor.
Thank you, doctor.
Thank you,
Doctor.
doctor.
Thank you, doctor.
Thank you, doctor.
See you.